So with this short introduction, I would like to start my presentation, Artificial Intelligence for Everyone, Part 3. You might have noticed that this is Part 3, so what happened to Part 1 and 2? And this is this presentation, I would like to keep it, modular, as if you are a newbie, you can watch this presentation without previous knowledge on Part 1 and Part 2. That's why I'm going to have a very short recap of what we learned during our previous two meetups. This presentation is mainly focused about practical AI aspects without going into any code, but how to apply AI in your organization or how to manage AI teams, stuff like that. It's also very much inspired by industry leaders such as Andrew Ng, Geoffrey Hinton, Andrei Karpathy, and Francois Colette. And most of this material is based on their books or their courses or their writing and other materials. And as always, I would like your participation, because it's not very interesting if only I'm talking. I'm going to ask you a lot of questions, and you will have to answer or raise your hands as in voting, and that's how our presentations usually work. So let's start with a very simple exercise. So who was here the last time? Wow, just 2 people. Okay. What happened to everybody else? And who was here on Part 1? Okay, more people. So let's spend 5 minutes on recapping what we learned during the previous presentations. And so this is the most important slide. I always have to find a balance between new members and old members. Usually it's more like 50-50%. Today the newbies very outperform the old guard. So I always have a problem that 50% are totally new and 50% are coming to most of the meetups. So first of all, it has to be easy for new members but interesting for old members. No coding skills, but should work for all positions and has only validated knowledge. That means no state-of-the-art and no unproven techniques. So with this framework, we can get to the actual meat of the presentation. So the first question is, what is AI? And that's an actual question for you. Who knows what's AI? Don't be shy. I said that for the last 2 times. So okay, yeah, that's a thing how you can make a machine learning or deep learning model using a perceptron. That's a good keyword, but let's go higher level. Let's not talk about implementation. Let's talk about what's AI for a person, like a layperson, a person who is not machine learning engineer, who's maybe a CEO of a company which might want to integrate AI into their product. There's no correct or incorrect answer, so be brave. Let me hear your thoughts.
It's a method of making a program to exhibit human-like intelligence behaviors.
Very good. So what he's saying is that program is exhibiting human-level intelligent behavior. That's in a way, I guess that's a quite good definition. Who else has their own opinion?
Well, I guess you get a dumb but powerful guy and you teach it, and then it works for you.
Can you repeat that, please?
I mean, a computer itself has big capacity of calculating stuff, but it's in a way it's dumb, so you have to teach it, and then it works for you more efficiently.
So what he's saying is that computer has this all computing power, and if you teach it, it kind of works better with teaching. you actually almost got the definition of machine learning. So what I want to show with this question, like again and again, that nobody really knows what AI is. Everybody has their own opinion. A lot of people are talking about, killer robots when we are talking about AI. A lot of people are talking about self-driving cars when we are talking about AI. A lot of people are talking about, so this model can like differentiate between like cats and dogs, and that's AI. And so AI doesn't have this one definition. And sometimes when you talk about AI with people, it becomes like clear that you're not talking at the same level and you're using totally different definitions. And then people try to get into very, smart arguments.
I think I remember what's AI. I think there's a quote about it. It's like if it's in PowerPoint presentation, it's AI, and if it's in code, it's probably machine learning or deep learning.
Okay, yeah, I've seen that too. That's not. It's I guess practical, as in AI means you are selling your company to investors. You are pitching it, and your AI is much more marketable term than machine learning. If you're saying machine learning, nobody wants to invest in machine learning companies. Everybody wants to invest in AI companies. So that's how this joke got started. What we define as AI, we actually split AI into two terms: artificial general intelligence and artificial narrow intelligence. And now everything becomes like very, very clear. Artificial general intelligence is the sometimes called super intelligence, strong AI, things like that. So human level AI, that means the programs from sci-fi movies, something like that might be considered artificial general intelligence. It means that the program might do anything what a human does, but better or at the same level. That's artificial general intelligence. And that's the thing which we don't have yet. And probably we are not even close. The other thing, artificial narrow intelligence, is the thing which we do have right now, which powers, Teslas and Google products and a lot of companies in like recommendation systems and image detection, stuff like that. We have that already. That's what we are actually learning in the workshops. We are learning to build artificial narrow intelligence programs. So with those two definitions, everything should be like very, very crystal clear about what we are talking. So in this presentation, note that we are only talking about artificial narrow intelligence. We are not touching the super powerful, smart computers which are smarter than humans. We are only talking about a program which does like one thing: plays chess very good, drives a car very good, detects if you have cancer from a CAT scan very good. So that's artificial narrow intelligence. Yeah, so that's what we are only talking in this presentation about. So given that, how does artificial intelligence relate to machine learning and deep learning? A lot of you are probably reading in the media that AI can now do this or that, or like anything, and most of the time that means that AI powered by deep learning can do this new thing. Mostly all of the innovation, what's happening these days in AI, is happening with the help of deep learning. Who knows what's deep learning?
It's basically a bunch of linear combinations with like activations, and then you use partial derivatives or gradients or vector values
All right.
to update it.
That's very true.
Approximating the function, basically.
Okay, yeah, that's you got the definition, I guess, pretty much exactly right. Unfortunately, it's not very clear for person who is not into linear functions with activations, what that actually is. So deep learning is basically this new branch of machine learning, which in turn is just a program which can learn from data. Basically, AI means it doesn't necessarily learn from data, exhibits some smart behavior, right? Imagine a chess program, like in the old days chess program. It was like superhuman, or at least a very high level player, but it didn't learn. Like you can play it a million times, it wouldn't get any better. Then the machine learning came, and now suddenly the program started learning. If you play a million times with a machine learning powered chess program, it gets better every single time. It learns from like your playing style, what mistakes you're making, how you are beating it, and it incorporates all of that into its like models and plays better and better. So deep learning is a branch of a smaller machine learning field, which, as he said, deals with linear layers followed by activations. That's technically how it works. In practice, I'll tell really, like in a very probably 2 or more slides, how exactly we should differentiate what's deep learning and what's not. For now, you should know that it's just linear layers stacked one on top of each other. It was inspired by the brain a little bit. Nowadays, it doesn't have like almost anything related to like how human brains work. So we have these 3 branches of machine learning: supervised, unsupervised, and reinforcement. What you should know is that most of what's happening these days are happening in supervised learning. Most of what the research is done is like supervised and reinforcement learning. All the game playing is reinforcement learning. Unfortunately, we are not actually very interested in AIs that play games. We are more interested in AIs that can do something useful. So what's actually applied in the industry? Most of the time, supervised learning. What's in the research? Like a lot of reinforcement learning, a lot of supervised learning. It's kind of almost a 50-50 split. And supervised learning, also popular, just it gets everything like made semi-supervised. As in traditional unsupervised learning methods are not that hot right now, but people came up with fake labels, as in making the problem somehow supervised, and then actually using that to train the model. So most approximately, you should know that if you're using AI in your company, most likely it's supervised learning. Can anybody tell me why is this happening right now? We have some helpers on the screen, but does somebody know exactly what these mean? Why deep learning is popular right now?
Should I answer again, or
Sure.
Somebody else maybe?
No, it's okay. We can talk to each other.
All right. Well, as I recall, it's mostly due to increase in computing power, and especially like GPUs. And the second one is the availability of the data. There's like data sets and information. The amount of data that people create over time is like increasing exponentially.
Mm-hmm.
So I would say these are the 2 main factors.
All right. Have you seen this presentation before?
No.
Yeah, I hope so, because I just created that. Now, he's right actually on 2 of these, actually 4, I guess, points. You're right on GPUs. So who knows what a GPU is? Okay, so GPU is a graphics processing unit. Previously, 2 groups of people used GPUs. Gamers first, because GPUs were initially built for playing games, or I guess, doing computer graphics when only games required that much power. All cryptocurrency mining used a lot of GPUs, maybe you heard about that. And nowadays, I guess all of that still retains. But NVIDIA specifically came up with a way to allow to use GPUs for this type of deep learning computation. And by the way, only deep learning needs GPUs. So that's how GPUs integrate into this deep learning driven AI explosion. Then we have data sets, and yeah, that we are getting more data. Another driving factor is benchmarks, as in previously everybody was creating their own models. Nobody knew who is doing a good job and who is doing a crappy job. Since we got competitions and more people started to participate in the competitions, the research kind of exploded because everybody was learning from the best of the previous year. So if somebody won the last ImageNet competition with a very new model, then next year all the models are going to be based on the previous year's model. So this way, instead of only building from your own knowledge, you're building from everybody's knowledge. And that really accelerated how things work in like how you prove that you're really better than everybody else and how you get the state-of-the-art results from everybody in the world. Finally, algorithms and architectures. So this is kind of fueling the benchmarks, and the benchmarks are fueling algorithms, because new algorithms help out create the new state-of-the-art. State-of-the-art helps to create new architectures and algorithms. So they're all related into this like self-helping cycle. So we have two types of data, and I promised that I'm going to tell you from a practical perspective what deep learning is. So machine learning is very good at dealing with structured data, like the classical machine learning, since deep learning is part of machine learning. So if it's tables like Excel, SQL databases, something with structured data, most often you can solve that with classical machine learning models. If it's something what has to do with unstructured data, some of that, you can solve that a lot better using deep learning. So what deep learning actually did, it allowed the computers to finally pierce and understand the natural world which surrounds us. Suddenly computers which couldn't understand what's in the image, now we can not only detect how many chairs are that in the image, we can also understand each of the face in an image and find a person, like Facebook finds a person in their databases and tags you, also you were in this event. So this is powered by deep learning. Deep learning allowed computers to understand videos, images, audio, natural language text. So if you're thinking about what's deep learning and what's machine learning, most of the time think, does it do with images, audio or text, and it's deep learning. So we have this 1 second rule, that's actually by Andrew G. And he says that if you can do something in 1 second, probably a deep learning model can do that too. These are the examples. So can you in 1 second classify an image? Is it a person or a boat? Is it a plane or a cat? You can basically do that in 1 second. That means computers can do that too. That's actually true, computers can do that. Can you detect where a person is or a car is in an image, like a self-driving car? If you're given a lot of images, can you do that in 1 second? Sure you can, you drive every day, or potentially humans drive every day. So it's pretty easy for us to do that. Powered by deep learning, AI can do that too. Language translation, that's probably a bit longer than 1 second, but close to that. So computers are starting to become human level, or sometimes even above human level in computer translation. That's actually very recent, it's just this year's developments. Sentiment detection, can you understand the mood of a comment? Is it a positive comment, neutral comment, negative comment? You can do that in 1 second. Computers can do that too. Finally, self-driving cars. A lot of that meshed into one, you get a self-driving car. So if you're thinking about starting your own deep learning or AI company, think about, can I do that in 1 second? If you can, then you can find engineers here, I guess in Lithuania, who can code that for you and how you get that type of startup. If it takes you like 30 seconds to do, that's probably what Google or OpenAI or Microsoft or Tesla can do, but not everybody. You need a huge research teams which might do this thing. And obviously that's a very hard approximation. There are things which are hard for humans and very easy for computers, and it takes you like 20 seconds or a minute to multiply two numbers, but computers can do that in like split of a second. But most of the time, if it deals with the real world, then apply this rule. Finally, we are actually at the start of our today's topic, practical AI applications. And there are basically a lot of work that has been done for the AI technologies to be introduced into our society. Still, we are not there yet. We still have a lot to do for the transition to be smooth and beneficial for everybody. AI, as you probably know, is a very powerful tool, and it can cause a lot of harm as well as a lot of like good. So we have to like create it in a way that we have to create AI products in a way which doesn't hurt people and actually helps out everybody, increases fairness versus, you know, just perpetuating biases. So let's start with the AI Transformational Playbook. This is how you would transform your current company to an AI company. And actually in my company, we are following this procedure to transition like our company to the next step. This playbook is made again by Andrew Ng. He created that after his experience in doing this thing for Google and then doing exactly the same thing for Baidu. Now he's sharing his all in to teaching people AI, and he's becoming one of the best resources of actual applicable AI for your company. So first, step one is to build projects, build pilot projects more specifically. Why do you need a pilot project? Can somebody answer me, Matt? Be brave. Yeah.
It's really difficult to sell something to stakeholders if all you got is, well, other people are doing it. You want examples, you want to say, hey, we solved this cool problem, so we have more money, more time, more people, so we can solve better problems, harder problems.
All right. That's very true. I had a different thing in mind, but yeah, yours is totally legit example. Who has some more ideas?
Inside the company knowledge about AI.
Can you please repeat that?
You want to build inside of the company knowledge about AI, train your people.
Yeah, exactly. So this is why we are doing this first step. Obviously, we are not just like blindly applying what Andrew Ng said. It's, you know, our money. So we like validated each step. So why should we just build, you know, some easy win, high success rate project first? Because there is a lot of missing infrastructure. There is so many things to get wrong. So choose a problem in a way that's easy for you to solve. And if you do that, then you have a maximum chance of actually delivering something. If you choose a hard problem, like a very business problem, as in, oh, so if you manage to do this thing, it creates like doubles our profits, that's actually a bad goal, because most likely you would fail since you have no experience in building that, because you're doing transitioning AI playbook. So you have no experience in that. You'll start doing it, you get frustrated, you get stuck, your project, your team fails, AI gets labeled as just this one additional fad which doesn't work in practice. Unfortunately, that's, you know, like a very severe disadvantage for your company. So choose a project which is solved a million times, like image classification or object detection are perfect examples how you would start, how we actually started in my company as for the first project. The second thing is hire consultants or contractors. It's not, you don't necessarily have to do everything by yourself. Get people who have done it before and get them to help you. So that's actually what we also did. We get some like free experience from people who have done that a lot of times. The second step is to build your in-house AI team. So sometimes this happens at the same time as building a project. It's not necessarily the like concurrent step. So this one means that you have to have, if you want to be an AI company, obviously you should have your AI team. Otherwise you just a company which hires AI consultants. So the AI team should start as a centralized team. That means don't diversify, don't hire like 5 engineers, 5 like AI engineers and put them in 5 different teams, because that's not how you're going to make it work. Like get them all into one team, get this one project, do a cross-functional project with some like business domain. And after you deliver this, after you deliver your first successful project, then you can think about next steps, as in diversifying and making your whole company being able to deliver AI products. So first, start with centralized company. The second thing, put that team under CEO, CTO, or Chief AI Officer supervision, as don't put that under one of the middle management, because that's, again, they might need some resources which this business field leader might not be able to give them without higher authority. So since AI is very different, the problems are going to be very new, and put that under the highest possible managerial person in your company. Also, the initial funding means that don't expect to get value immediately after a couple of months. Probably your project is not going to be ready. Even if it's ready, even if it's successful, you have chosen a project which is not by definition most important for your company. It's an easy project. So you should provide some initial runway for this team to start out. The third thing is to provide broad AI training. So after you have your team and have your first project, like pilot project, successfully, you should tell everybody about how you're doing AI, how it works, why you are doing that, and basically provide training for everybody in the company. That includes top management, that includes team leaders, as in leaders of business divisions, that includes all other employees, as in maybe a huge company-wide presentation about how we are doing AI. And finally, that includes some junior people who want to transition to this role, for example, from data scientists or from software engineers. After you get the training done, you should then develop your AI strategy. And Andrew specifically says that this should not be your step one. Naturally, you would want to say, okay, so this one might be the step one. As you know, these should all start with strategy, broad level goals, then go down to practical implementation. Unfortunately, that's not how this works in reality. Since you have no experience and no knowledge about AI systems in your company, if you start with this broad, uninformed strategy developed by top management, it will be super hard for the actual team to achieve the strategy, to implement the strategy. So that's why only after you have some initial successful projects, and only then everybody has at least a bit of understanding how the AI works in your company, only then you actually start using AI for your business goals. Okay? So this one leads, if you do this successfully, it leads to virtuous cycle of AI. That means if you implement AI in your product gets marginally better than the competition's. If your product is better, you get more customers. That means you get more data. If you get more data, your model gets better, and this better model leads to even a better product. And this cycle continues and continues. That's why AI helps you to build a very defensible businesses. For example, Google has made a very defensible search engine business. I mean, it's not like super hard to make a search engine. We learn that in like computer science at university. However, Google has so much data, it has so much infrastructure, they have so good models that it's pretty much impossible for even largest companies such as Microsoft or Baidu to catch Google in the search engine game, because Google has like this like virtuous cycle of AI going very, very fast. So what does that mean for your company is you shouldn't try to fight the biggest tech companies in their game. Find your own AI niche. That means if you're doing, I don't know, agriculture, automobile manufacturing, transportation, whatever your company is doing, implement AI in this niche. Be the best in your thing in AI. Get the most data in your domain. This way, even like largest companies such as Google or Microsoft or whatever, they won't be able to touch you because you have so much more data. We have so much more experience in this field. It makes it very defensible business like strategy. Finally, we have like additional part of AI strategy. That's a data strategy. So since data is the fuel for AI models, you should try to get as much data as possible. How do you do that? First thing is strategic data acquisition. If you find a smaller company which has a lot of data, you can do that by, you can like buy this company and acquire all of their data basically for free, instead of trying like very hard for a few years, stagnating your progress. You can immediately get that and continue on your AI strategy path. The second thing, if you have the data, be sure to integrate it. If it's separated into like 5 warehouses, there's no way to, like data warehouses, there's no way your AI engineers will practically use that. So actually what we were lucky, since in our company we already had a unified data warehouse, and the AI models could immediately start using that in our actual product. So like some starting points also differ from company to company. The final step is to develop communications. That basically means you have to talk with investors about your like AI strategy, government, especially if you are working in a very regulated businesses such as like medicine or law or finance, consumer education. In Europe, we have this GDPR thing, so you must tell your consumers that you're learning, that you're using machine learning for your model. Also, the same thing is, pretty much a decent thing to do if you're working with non-European customers. Finally, it kind of is nice if you have an AI team. It puts a bit of a like prestige in your talent acquisition and recruitment. We actually felt that since we got the AI team, it was a nice thing to tell new hirees that if you want to like work with AI, there is this team which we are actually trying to implement AI solutions to our product. And obviously internal communications, that means that everybody should understand that how your AI strategy is going to unfold, that we are not being replaced by these algorithms, and that we are just trying to make the product better instead of optimize your job. Do you have any questions about the playbook? I was on a very rapid firing mode.
Company you're kind of saying which can start AI.
Yeah, so that's
For example, in the Lithuanian market, it's should have, what the number of employees, what are the data, I mean.
That's the thing, that it doesn't matter. Since you are going to use AI in your particular domain. That's, if you are doing, I don't know, give me an example.
I want an example from you. Maybe you have some examples of Lithuanian companies which start with AI.
Okay, so obviously I can give you a few examples. So first of all, what helps? It helps if you are a tech company already. That means you have a lot of the infrastructure already built in. You maybe have your data warehouse. You might like get some data from your websites. If you are totally into like hardware or offline businesses, you would have to build that too. That's not undoable, but it will be harder. So it helps if you are a tech company already. Does not necessarily mean that that's the limit, but it helps. The second thing, if you are a startup. So if you are a startup, you're in a perfect position to immediately start using AI for your product in the beginning. We have this one example in Lithuania, Oxipit, which are like people who have just who were good in Kaggle competitions, especially computer vision tasks. So they decided to make a startup like in medical, like AI for medical usage.
But anyway, what are the typical industries which are benefiting? Banking, GSM, or there is no such thing as typical industries for this?
Probably. So it depends on what kind of AI product of AI solutions you want to implement. Like the most fascinating ones are the ones which deal with real-life data, which uses deep learning. So for example, if you do banking, you probably don't get a lot of, I don't know, photos. You would use the classical machine learning techniques, and they are doing that already. Banking has been doing machine learning for a lot of time to get frauds, to get like models, risks, and stuff like that. So that's basically nothing new. The thing which was unlocked just recently was the computer understanding of the real world. For example, you are like a car repair shop, and somebody comes to you with a car which was in an accident. So you could just use your computer vision model to take like 10 photos and immediately estimate how much is it going to cost for the user to fix this damage. You don't have to get your one expert to say, oh, so this one is like 600 euros. You can do that, like take a camera and do that and get an estimate from your machine learning model. Right? Yeah, thanks. Good question. So, since we have finished with the playbook, let's talk a little bit about bias and fairness in the AI, like how to build your products in a way which is fair and non-discriminatory for people. We have this one like famous example that if we build a language model is basically a model which tries to understand how each of the worlds relate to each other. So if you give the model, like you train the model on the internet, on the data on the internet, this is what you get. If you give it a man as to woman, you give it a father, and the model predicts that's a mother. So the first one, this one, is the input. This is the vector, this is like the dimension on which you should move. Then you give it a new starting point, and it predicts this next word. Okay, so a woman is to a man as a mother is to father. Okay, makes sense, right? Does it make sense?
Yes, sure does.
Can I get a raise of hands if it makes sense? Perfect. So the next one, same example. Man to a woman is a king is to a queen. Still nice, right? That's expected. The next one is not so nice, since a man to a programmer is a woman to a homemaker. This is like an actual what some model, I don't know, like a few years ago actually learned, and unfortunate because the correct answer is what? Yes, very good. So a man is this like exactly as capable of being a programmer as a woman. So it should be a programmer. Unfortunately, if you like map it out on like this vector, you would see that the vector is just going like this direction, and if you start from a woman in this direction, you would get a homemaker. It's like nobody's fault except for the people who get the data. They're lazy and get all the data we could. Do you know this example? Have you seen it? Who has seen this example? Okay, a few people. Do you know the company which did that? Try to guess.
OpenAI.
No. That's...
No, is it Google?
Is it what? Sorry?
Is it Google?
It's Google, yes. Google did that. How did they do that? They haven't trained their model on enough black people. So that means basically how it works. Most of the Google engineers are like white middle-aged dudes, and they don't like take into at least initially they didn't really thought about like if we scrape the internet for images, or like basically Google has most of the images from the internet, so they just take all the images they can randomly and then train their models, and that is how you get these things. So you have to be really smart about the way how you like source your data. We had some more bad examples, such as hiring tools which were gender discriminatory. That means like this automatic tools gave women smaller chance or smaller rating with exactly the same parameters as for men. Then with face recognition, were like more like they were predicting that the criminal is mostly like black people or Hispanic people. That's in America, obviously. Lithuania, that wouldn't work. Finally, bank loans were discriminatory against minority people. Why do you think this happens? Is Google evil? They said, don't be evil. Are they evil?
No.
So how did this happen?
Google and all the social platforms are filled with what people fill it and filled with. So, like if you go to a racist subreddit, you won't train your AI much. So.
Okay, yeah, that's most of that is right. You cannot just take all the data from the internet, because we get this problem, what's called in statistics omitted variable bias. That means that something else than race had this like why is data, I mean, some people argue that look, so if we like take randomly women and men or like whatever, like white people and black people, we get like my model is right? It gets like 95% accuracy. This is because the model learns the wrong thing. It learns to associate race instead of some other variables which the programmers didn't bother to put in. For example, the years of education, income of the parents, or something else which is actually a predictable variable. But overall, since it just so happens that previously it was that like why black people don't pay their loans as good as like white people, the model learns that, oh, so that's the easiest way to learn that. This is why you cannot omit variables, and if you do that, don't put race or anything which might be like used in a way which is unfair. So this is the problem, as people omit features which are actually predictable, then the model falls back, it learns it any way it can. So the model falls back and learns the wrong thing. Yeah.
I mean, the other option, if you're using hiring tools and say you use a database of CVs and you use whether they've actually hired a person or not as the label, you might have all the data and you have the correct labels, but you end up encoding an implicit bias.
Yeah,
So
exactly.
it's not identified, but it's still there, and it learned the right thing. It learned that you're biased against black people or whatever.
Exactly right. If you are already racist and sexist, the model learns that. So like let's start like fix your like obvious problems first. I mean, maybe you want your model to be biased then. Maybe that's your goal. You are evil company. So if you don't want that, obviously fix your actual models, or maybe this is how you find out about that you are evil and you should change. Then change it, then fix your model. I have some example from deep learning, which I really want to like drive this home. This is very important. That's why I'm spending so much time on that. There was this famous military deep learning, like actually it wasn't deep learning, it was a model which detects tanks versus no tanks. So what they did, they photographed, like one day they put some tanks in a field, they flew a plane, photographed the field, landed like I think, or drove a truck. Yeah, basically it was a plane. They made a lot of photos of tanks, like with camouflage against a forest background. So the next day, they put all the tanks away. They flew from the same place, take like similar photos, then train the model on these photos, and the model got like over 95% accuracy. They were so happy. They tried to use the model then in real life, and the model was very, very crappy. It didn't like, it has a 50% accuracy, the same as random toss. Is there a tank or is there no a tank? Is there no tank? Basically, the model didn't learn anything. The problem, as it happens, was that the model learned that one day it was sunny and the other day it was cloudy. And it's a very easy thing to learn, since the top pixels of an image are very light on all the images with tanks, and then very dark, or not, like much darker in the next images which don't have tanks in them. So the model, it doesn't know should I learn about tanks. It kind of tries to find anything which makes it more predictable. So don't learn the wrong thing. Be sure that you're learning the right thing. How do you do that? Either remove the background or like shuffle the background in deep learning, or in like these other types of applications, don't put this data in, or then shuffle that if your decision does not, like if your model should not take that into consideration. That's what happens to like a lot of companies. Just take any data they have, they put deep learning on this data, they don't get a fair model, and they said, oh, we didn't do anything. Like we were so fair, we just got the actual data, right? As he said. So if your data is bad, if you are omitting some actual predictors, the model learns the wrong thing. How to solve this? Basically, there are technical solutions. There is like transparency and auditing and diverse workforce. So you should use all of that, all of these solutions. Try to identify what's causing bias in your models. Try to get more data, which is actually inclusive. So as an example with tanks, try to photograph your tanks against a forest, against a field, in a sunny day, in a cloudy day, in rain. Like get more diverse data. The same one applies with like bank applications or whatever hiring tools. Finally, if you have a diverse workforce, it might help you not to classify people as gorillas anymore. Somebody might, can I try that? Oh, it says I'm a gorilla. Maybe let's like investigate. What do you guys think? So this is like the most tried and true ways how to fix it. Let's move to the next one. Do you know this one?
To help families refinance their homes, to invest in things like high-tech manufacturing, clean energy, and the infrastructure that creates it. You see, I would never say these things. least not in a public address, but someone else would. Someone like Jordan Peele.
It's sort of learning to recreate that person's face by looking at thousands of images over and over and over. There's a lot more research than you would think would go into making a goofy video or something like that.
Truly surprising for me. Yeah, I was just really surprised.
I didn't do any after touching on that video. That was just using the technology that was available from the machine learning side.
You don't even have to know what GitHub is. You don't have to know how to program in Python. None of that matters. You pay somebody $20 and they'll create the fake for you. That's a bit of a game changer.
You know, the everyday person who the deep fake sex video emerges in a Google search of your name, where for that person, it becomes almost impossible to debug.
While I don't think that's likely, I also don't think it's out of the question. And that is enough to keep me up at night. The margins are very, very thin. Last national election here in the US was 80,000 votes in 3 states. You don't have to fool tens of millions of people.
I don't think deepfake will become a big political issue during the course of the campaign. Think about a well-placed rumor before an IPO. I think a lot of these things were problems already. And so it's unclear to me how much machine learning really, adds to those problems. I find it very difficult to sort of believe that there's something so uniquely devastating about video.
There was that thing with Elon Musk recently.
Cannot change slides.
It was a deep fake as well.
I haven't seen this one. Can you shortly describe what it was?
Well, they moved the face of Elon Musk onto a child, 3 years old, and created I guess, quite a long video about him being a child and living in a family while having that, face of an adult. So yeah.
Okay. Yeah. So as you can see, who thinks that this might be problematic? All right, good. I got you to think about it. I'm happy. So deep fakes are kinda. Do you know what's a filter bubble? Who knows what's a filter bubble? Okay, some of you do. Filter bubble basically means that since the recommenders in Facebook, Google, and most of the platforms learn from what you actually search, they show you results on which you might be inclined to click. They want you to click on whatever they are showing. That's how the machine learning recommenders work. So if you, for some reason, search for is 9/11 an inside job, or is vaccines making you autistic? So these things, Google kind of learns that. It might know that that's not true, but it will show you all of your front page about why vaccines are actually causing you to get some illnesses. If you click on those, you get more recommendations like that, and you get into this filter bubble, as in Google will not recommend you the actual true, millions and millions of true articles. It will show you the hundreds of fake articles and things which are not true. If you are only exposed to this type of data, you think that that's true, since it's all over the internet, but it's only all over your internet. So this is how filter bubble works. It's nobody's trying to be evil. The recommender systems are just trying to show you something on what you might click, and since you clicked on that, it will show you similar things. So given, in addition to that, deep fakes, as somebody which you respect is saying the thing which you believe, Now it kind of gets it all to the next dimension. Now you might be like super convinced that that thing is true, even though nobody said that. There is just a few examples on the internet of that thing, but for you it might look like that that's the whole truth and there is nothing against that. So this is like deep fakes that filter bubbles can cause serious miscommunication even in our like very, very well connected world. Next thing, since the computers can do very good face recognition, we hear about things like oppressive surveillance. Have you guys heard about San Francisco ban on using face recognition for investigating crime? Yeah, I see some of you have. So San Francisco actually banned usage of facial recognition for police work because the models are not fair yet. They are like they are discriminatory against minorities. They have some other problems. They like wrongly identify people with like much higher probability than actually like for humans. The people don't look similar. The model says, oh, these are the same people. So lots of issues in this one. So if imagine a country like China, which uses these technologies like in a very large scale, how that can be a problem. Finally, the models get very good at generating fake comments, political statements, and product reviews, since it's all based on the same deep learning, like understanding natural language text, generating natural language text. I have an example, but I'm going to show you like during the last session, during the meeting session, about how you can talk to Transformer. So if you would like to try that at home, do that. I'm not going to show it right here since we don't have a lot of time, but I'll show it. I'll show that to you during the last part of the meetup. Now I want to talk about how to fight these adverse effects. So first of all, imagine that as being like we dealt with this problem before. It's called spam. Computers generate spam, or some people do that, but a lot of computers do that. Then we developed anti-spam filters, which try to guess what's spam and what's not. And currently, the spam filters are obviously winning. Have you got a lot of spam lately? Who got? Nobody. That's because most of you are probably using Gmail. And Gmail has really state-of-the-art anti-spam filters. And this thing, I expect, will become this dynamic will evolve with deep fakes, fake comments, and stuff like that. It will be just filtered out because the computers, since humans are not very good at detecting deep fakes, but the computers, they might be as good at detecting deep fakes as we are good at detecting spam. So it will become like a race dynamic between filters and generators. The next thing is policy decisions. So I already told about San Francisco. The next one is GDPR, which kind of forces the companies to show you what data they are collecting about you. So if you didn't know, you can ask any company, what data do you have about me and how you're using that. Finally, I want to talk about a little bit about job automation. So since this is again a social issue, the McKinsey Global Institute made a study about what jobs will be automated and will more jobs be automated versus the jobs which are not automated. So what we found out is that there is no need to worry. The AI will create more jobs when it automates. Unfortunately, there is a problem because even though the jobs are created, it's pretty hard for a truck driver to become a machine learning engineer overnight. If Tesla develops a self-driving truck, it will be pretty hard for the truck driver, to requalify. So these challenges are suddenly the responsibility of a state, that they should adapt their citizens for these industry disruptions and like get people to do more like lifelong learning. What jobs are in the risk of being automated? So first of all, the risk of automation is, as always, manual labor. Why do you think that's the case?
Easier stuff.
Most of it, actually, automation usually means not automation of jobs, more automation of tasks. And we have like a lot of experience in automating like the big industrial, like car manufacturing, or I don't know, like anything which does not involve a lot of reasoning. The thing about reasoning is that the current systems, the current machine learning systems cannot do that. They cannot do reasoning, planning, and creativity. There are some exceptions. Computers do some music creation, but despite that, not like regarding these examples, most of the jobs are going to be manual. That's like extra challenging because the companies like not the companies, the countries, the developing countries, which usually started out with creating these like low added value products, now they become in a risk of being like unnecessary. So previously, how should like the playbook for a country which is like a developing country, they started manufacturing some low added value production. They increased their like knowledge, they increased their added value, and they became like, you know, like Japan manufacturing of electronics, China manufacturing of basically everything. So these options might not be available for the next iteration of developing countries, because you don't need labor intensive, like a lot. The labor becomes less valuable because robots are as cheap in China as they are in like America or in Europe. So that's why it's dangerous, dangerous for the developing countries to rely on their cheap workforce as a competitive advantage. And how should a country, how should a developing country fix that? First, use AI to improve your advantages. The same applies as with companies. Don't try to compete with world's leading economies. Try to use AI for your own thing. Provide legal framework. Utilize public-private partnerships, especially in the highly regulated industries, because that's the private companies are not they're afraid to go on their own. However, a public partnership, the legal AI or medical AI might really be a strong point, because you are helping the companies figure out all the legal nuances in your country. Finally, invest in education, as you need the lifelong learning, because some of your tasks are going to be automated, some of your people are going to be out of work, so we need to start thinking about how should we fix these inequalities which might rise. So thank you all. I bet I went a little bit over my time limit. So do you have any questions? Sure.
You mentioned that there are models created to analyze all the different situations. I assume there should be some kind of model validation thing, just to when you create that model, is there anything you can compare it to, and just make sure that it will do something reasonable and that kind of stuff?
Yes, that's actually true. We always do a couple of levels of model validation. So we have a separate, we imagine or pretend that we don't have access to this data, which we actually do. when we try to validate how we expect the model to work in production. That becomes, we learn from the mistakes of Google and, the companies which were first in this industry. Now we have these best practices, how to avoid these embarrassing mistakes. You are very right. We have, validation data sets, holdout data sets, test data sets, all of which are just for validating if the model is doing what we expect it's supposed to do. Any more questions? Yes.
Now, this artificial intelligence is very popular. It's hyped, and many things on the market now, they are named as artificial intelligence, but it's not. It's just an algorithm. I don't know, like that. Are there any criteria or I don't know, standards where we can say is it just algorithm or artificial intelligence? What is your view? Because even I read some article that among the startups which mention artificial intelligence, what they're doing is it was kind of audit performed and only 60% of them were artificial intelligence. Another use this word. So what is your view on this hype of this word, and are there any efforts in industry to distinguish where true artificial intelligence and where it's just a program?
All right. So I know this study which you are citing. It's about the European startups which claim to be like AI startups. The problem, as you identify yourself, is there is no clear definition. Does an algorithm start being AI, right? The original definition of artificial intelligence actually allows that, as I don't remember, but somebody said just a computer program which has what it looks like to be an intelligent behavior. But under this definition, like so many programs can be classified as AI. It just, unfortunately, this became a marketing term, especially marketing to investors, since if you get like twice more money by saying you are AI, why wouldn't you? And that's, buyers beware. If you are an investor, please get their code. I would much rather, I would be very happy if it wasn't artificial intelligence, but deep learning, because this one actually makes much more sense. This one is the thing which you can validate using deep learning as a core feature of your product. If yes, you are an AI company. If no, then you are just another tech company.
And about neural networks, are they necessary to have neural networks behind?
Yes, deep learning is synonymous with neural networks. So if it's deep learning, that means it's neural networks.
The latest example, I'm doing some photography, Canon released a new flash which have a claim to have artificial intelligence, just point to the ceiling automatically with motors.
Mm-hmm.
And it's not, for me, it's just an algorithm. It's have nothing to do with neural networks with deep learning.
It might have. It's hard to tell, you have to get the source code.
Okay, thanks.
All right, so thanks for your questions. Now it's part for networking, and I'm going so I would welcome everybody to stay and talk about what you learned today. I answer more questions, and I'll later show you the Talk to the Transformer website. Thank you all for coming, and I expect to see you next month in our next meetup. Thank you.
You mentioned all those workshops and stuff, and that people are learning stuff.
Are you an English speaker or a Lithuanian speaker?
I'm not much of a Lithuanian speaker.
Okay.
So, yeah. So, what about those workshops?
Mm-hmm. So, workshops are actually closed since we are at full capacity.
Yep.
On the other hand, we might have new classes next month, or at the latest the next month.
And how to know about that?
They will be will be announced on our Facebook group. So just follow. Like, we don't spam in the Facebook group. It's only relevant information.
Facebook group is